Joyce-san, thank you very much. So, everyone, good evening, good morning, and good afternoon. So, at the first UNISEC-Global meeting within the 2026, I'd like to say that a Happy New Year. I hope that 2026 would be a very fruitful and a happy years for all of you. Okay, so today I'd like to talk to you about the next step of UNISEC-Global IoT Constellation project. As I already announced in the several UNISEC-Global meeting, we announced the opportunity of your participation in this IoT Constellation project in 2 years ago, November 2024. We made this announcement in the UNICEF Global meeting in South Africa. And since then, I have been coordinating the activity of this IoT constellation project with you. And tonight, I'd like to show the next step. What will be the next step for us? Okay. So please go to the next page. So I don't have to say about what is IoT mission, but I'd like to say again what is IoT mission. So if you want to put several sensors on the ground, like for example, water level sensor, water quality sensor, or soil moisture sensor, or pH sensor, and so on. But if there is no ground infrastructure of the communication, in order to get the data from these sensors, you should go there to pick them up. So that would be very time consuming or even very dangerous at the time of the disaster. So if you put a small transmitter to this sensor, which can send the data into the sky, then when the satellite flies over that area, the satellite automatically collect the ground information. This mission is called the IoT mission, or sometimes it is called the store and forward missions. And recently, many activities of experimenting this IoT missions or some appear, and also some companies who start the business using this IoT mission already started. And we would like to have the collaborative missions within the UNICEF Global framework for these IoT missions. And as you see in these figures, we experimented this IoT mission in 2018's launch at Toricom 1R 3U CubeSat. We put a small receivers in this Toricom 1R, which can receive the very weak ground data from the ground transmitters with just a 20 milliwatt, very low power transmission would be possible. So this is very important for IoT mission because these sensors will be distributed in the outdoors. So in that case, it is very difficult to obtain a large power. So the very low power transmission is very important. So we succeeded in transmitting the data with just a 20 milliwatt. That is a starting point of this IoT missions in our project. Next, please. Okay, so this is a 3U CubeSat, and I lectured about how we can develop IoT satellite in the series of the lecture, which was taking place in last summer. And so this is one example of IoT transmission, IoT receiving satellite, which is just a 3U CubeSat, Tricom 1R. And maybe you can see that it is very simple type of the receiving satellite would be possible. Okay, and this was already tested in space in 2018. Okay, next please. And so this is core of the this IoT missions, which is made out of LoRa module. And maybe you can see that the LoRa is very popular communication module, which you can buy even in many countries. And we can make this LoRa module for the space-rated one. Okay, in order to consider about, for example, radiation hardness and so on. And we put these LoRa into our satellite. And as you see that we have 8 channels. And this LoRa module can also be used on the ground side transmitters. Maybe you can see in the right upper figures, if you have a 3 by 3 centimeter LoRa module, which are connected to the antenna, such as a 10 centimeter by 10 centimeter patch antenna, and these can make the very simple ground transmitter. And this module should be attached to your sensor. Okay. And then you can send the sensor data into the sky periodically. And when the satellite flies over your area, the satellite can collect that information. Okay. And the next, please. And maybe this kind of IoT missions can be applied to the many type of the solving the social problems. The one example is monitoring animal movement over a wide area. If you put the GPS sensors in the body of the animal, like an elephant in this figure, and then this data will be transmitted by IoT transmitter into the sky, and this data can be obtained and downlinked to the ground. Then the headquarter can detect where this animal exists, where the animal is. So this is very, sometimes very important to prevent the animal hazard and so on. And the next application would be the wildfire detection. If we put many, for example, temperature sensors in the forest, and these sensor data will be accumulated into the one place, and then the data will send by IoT communication to the satellite, and then you can monitor the temperature in the forest. And then if the temperature gets high, maybe you can detect the forest fire in the early stage. So early stage detection is very, very important. And the lower left figures show the flood detection and monitoring. So maybe the water level sensor can be developed with very, very simple mechanism. And if you put such kind of the water level sensors in the wide area of the river or lake or some other place, and then water level information can be obtained by these kind of the very cheap and simple sensors and transmit to the satellite. And then you can monitor or predict the flood of the river and so on. And the final one is the agricultural field monitoring. Maybe if the water is not sufficient for the agricultural field, maybe you can detect such kind of the lack of the water, or pH or moisture level of the soil can be monitored using IoT information. Okay, next please. So, what is the merits of IoT mission as UNISEC-Global collaboration? I think there are many merits utilizing this IoT mission for the UNISEC-Global collaborative type of the mission. So let me show some of them. The first one is that even with small number of satellites, you can do certain missions. And the more satellite, the higher time resolution would be obtained. So number of satellites will be increased with more fund obtained. But even if only one satellite, we can do a certain missions. Developing only ground sensors also contributes to the overall program. Okay, maybe there are many countries included in the UNICEF Global. Some country, the people already have the fund and skills to develop a satellite. But the countries which just started the space activity, it is very difficult for them to develop such kind of the satellite. So even for that kind of the country, developing the ground sensor can also contribute to the overall program. Okay, so as a result, the first step to enter the project is much easier and less expensive. And if you develop good sensors, you can also sell to the other countries. So if you have a very, very good sensor, which is a worldwide well-known sensor, become well-known sensor, then you can sell such kind of sensor to the world. That may make a certain kind of the industry. And you can prove to your government that space technology are really useful to solving various social or global issues. So this is very, very important for many countries to continuously get the fund from the government. If the government thinks that space technology is very good and indispensable for solving a certain social problems, then they are very much interested in investing a lot of money to such kind of the missions or project. Okay, so this is very, very important. By utilizing this kind of the IoT missions, you can prove to your government that the space is very, very useful. And in future, we would like to contribute to all the humankind by providing various data obtained all over the world. So maybe as you know, the sustainability programs occurs all over the world. And I hope that the space technology can, have some contribution to this solving this kind of the problem. So, for example, if the satellite has a lot of type of the sensors or IoT sensors on the ground can collect the various type of the information from the globe. Then we can, combine such kind of the information to find a certain way to solve the global, for example, warming problem and so on. So this is the merits of the IoT missions. Next, please. And as I said, we started this activity in the 2020 2024 UNICEF Global Meeting in South Africa, Stellenbosch. And last year, the first step, I asked each person to propose a certain IoT mission in your country, and we received 28 mission proposals from 22 members. And in the second step, we asked each country to search for the frequency which you can use for IoT missions. So we already collected several frequency band from 144 to 2400 and so on. Okay, and some are required. Some requires the licensing, and some does not require the license. So we should make a very good strategy to which frequency to use. And in the third step, we asked each, members who proposed the IoT mission to search for the sponsors and users for your own IoT missions. So in this step, I asked every participant to have a meeting with your government or local organization persons, and you can and ask them to check whether the sponsoring possibility would be happen or not. Okay, and the fourth step, step four, I made a lecture on satellite design, especially focusing on the IoT satellite, 3U IoT satellite. The lecture started in July, and we have 5 days lecture, and we already, gave the homework to the participant, and we collected, I think, a total seven, homeworks. So, I think that if you want to do this kind of the homework, please do it and submit that to the UNICEF Global Secretariat. Then we can check and whether your answer is okay or not. Okay, and please consider such kind of the making your homework again. And in the last UNICEF Global meeting, which was held in Tokyo in the last November, we did IoT workshop. That is very, very interesting workshop. So first I showed the how to make a IoT standard. So that is the first step. And then we did an actual experiment to send the data into the sky. And this data is collected by ArcEdge space satellite and sent back autonomously to the ground. And we checked that the sending information is really received by the satellite and sent back to the ground. And we succeeded it was very, very, enjoyable workshop. And I hope to have the next, Nano-satellite symposium will also host this kind of the IoT workshop. And this next nanosat meeting will be held in Taiwan in this year. And I hope that we would like to have the IoT workshop again at that occasion. And so, what is the next step? So next step will be the experimentation of you for you to send the data to the satellite. Next, please. So we'd like to give you some occasion to experiment IoT transmission to Arc-Edge space satellite. So this is the next step. And in order to do this kind of the experiment, I'd like to ask you to develop LoRa transmission module with components which you can buy in your countries. So LoRa is very, very popular all over the world. So that means you can also buy the LoRa module in many countries. So that is not so expensive. And I hope that in our mission, in our, our international IoT collaboration project, we would like to define only the standard of IoT transmission. And based on that standard, I'd like to ask you to develop the LoRa transmission module by yourself. Then you can, start this kind of the experiment with not so much money. Okay? And the required specification for LoRa module will be provided by Arc-Edge Space, such as the frequency, bit rate, bandwidth, data length, and so on. And maybe it's very difficult for you to develop the LoRa module from scratch. So a simple guidebook on how to develop the uplink system will be provided too. And the recommendation on antenna shape and gain and other specification, it will also be given too. And as to the frequency, there may be many candidates of the frequency for the IoT missions, but first, we would like to focus on 920 megahertz band. In more detail, 920.6 to 923.4 megahertz transmission frequency as the first step to match the receiver on Arc-Edge space satellite. And if you develop a LoRa module which can send the data within this frequency, and if that data is, match the standard, then the Arc-Edge space satellite can receive it. So this is the experiment. Please contact your government's communication authority and ask them how to get a license. Or sometimes it may be license free to use that frequency to send the data to the satellite. And maybe you need to take some effort to get, for example, temporary experiment license. And later, Tsuji-san will show you how to make this kind of the license process in your country and so on, using some example of some countries. And the other frequency, such as the bands around 868, 915, 400 will also be considered in future. Okay, and maybe the Arc-Edge space satellite will have this kind of the receiving frequency, but at this moment, please focus on using 920 megahertz as a first step. And Arc-Edge Space will announce a period of IoT experiment campaign. Period of IoT experiment campaign sometime when you can send the data to a satellite and check the connectivity. And detailed information when and how will be provided by Arc-Edge Space in near future. Okay, it may charge a certain handling fee. And we will highly recommend you will do ground-to-ground transmission test before that campaign, of course. So from ground to satellite communication should be done after you successfully made a ground-to-ground transmission test. Okay, so for that transmission test, you can use the LoRa module as well. Next, please. So this is the final page. So as I said, standardization is very, very important. And we don't, want to ask you to buy a certain component from a certain company, but we would like to ask you to make your own module or even buy a certain component from a company which can meet the standard. So then you can make the IoT ground transmitter, and then you can make IoT missions easy, much easier. And based on the standard, participants can develop their own components by, for example, purchasing off-the-shelf component that can be obtained in participant country, or developing the component by themselves. So depending on your skills or fund, you can do the various type of participation in this IoT project. So standard is very, very important. If you buy or develop such component, Arcade Space will provide some ways to confirm that the components can meet the standards by connection check or other means. So this can be done, as I said before, in IoT experiment campaign. Arcade Space will provide a simple guidebook on how to develop IoT transmitter system. And in future, Arcade Space will also provide IoT transmitter components, so it may be not free, and which are already proved to meet the standard. If the other company's IoT transmitter meets the standard as well, also you can buy and use it. So this is tonight's content. And if you have some more questions for inquiry regarding the IoT transmission to Arcade satellite, please contact the addresses below. Okay, this address. So this slide will be posted on the UNISEC-Global website later, and please check this website. This address. Okay, so this is the end of my presentation, and now I'd like to ask the Tsuji-san to show you actual experiment in some countries. Okay, so Tsuji-san, please.